Welcome to the Probability Podcast. Discussions on emerging and converging technologies, problems that are being solved, and the probability of positive and negative outcomes that we might expect. Now, please welcome your hosts, Jason, the generator Spracklin, and Patrick, the discriminator Lozon.
Hi everyone. The topic for this week is nanotechnology. Scientists have pushed the boundaries of what's possible at the nanoscale, from the discovery of gold nanoparticles in the 19th century to Richard Feynman's groundbreaking vision of manipulating atoms. Today, nanotechnology is revolutionizing fields from medicine to environmental science, while also raising important ethical and safety questions. So, the questions for discussion today are: what is nanotechnology and how did it evolve through history? What are the latest advancements in this technology? How is this technology transforming industries? And what risks and concerns are associated with this emerging technology? So what do you think, Patrick? Are we ready to enter the microverse?
It works. Diane, I got something real important to tell you.
Are you trying to tell me the machine works? Do the kids know?
Well, yeah, the kids know.
That's great.
It's not that great.
Why?
I shrunk the kids, and the Thompson kids too. They're about this big. Threw them out with the trash.
We threw him out with the trash. Well, let's first define that. What is
that was my first experience with nanotechnology was Honey, I Shrunk the Kids. So
Okay.
this is one of my favorite movies as a kid. I mean, for a long time, that's what I thought the usage of nanotechnology was.
So unfortunately, nanotechnology is actually even smaller. So when they talk nano, they're talking 1 to 100 nanometers. And like 1 nanometer is like 100,000th of a human hair. It's pretty damn small.
Yeah.
And the idea behind that is, well, once you get into technology that's manipulating matter at that level, what are you capable of, right?
Mm-hmm.
So anyway, let's first start with the kind of the history that you talked about. You know, back in the bad old days, ancient Egypt, they were using soot from oil lamps to create pigments for writing. Okay, so very tiny little elements which were, basically being utilized to draw, create ink, right? So, and of course, nanoparticles to modify colors, and with that, you get, different forms or hues of color. Things got really interesting with in the late 1800s with Michael Faraday, and he discovered gold nanoparticles while he was messing with gold leaves. Now, I don't know how, who had his budget, but all of a sudden he has gold leaves and he's messing around with gold. So I think they started getting serious with nanoparticles, or really trying to modify and play with nanoparticles back in the early 1900s. But it wasn't until late, or mid 1900s, when physicists, like we had mentioned, Richard Feynman, he talked about, he was quoted as saying there was plenty of room at the bottom, and what he was talking about was there, the space in between atoms is incredible, right? Once you start looking deeper and deeper and deeper on a microscopic and then subatomic level, things are very, very, very far apart, right?
Yeah, they're talking about the building blocks of life, essentially, right?
Yeah, and you start thinking in the same references as us in the celestial, in the stars. Not maybe not the same level. And the idea is, things could shrink down. You've got a lot of space to play with, right? So that's what he's trying to say, right? But anyway, so let's jump into this. What happened? 81. There was something called the scanning tunneling microscope. was created by IBM Labs. What they did is they used a tungsten, tiny little tungsten. We'll call it a needle, but it was a very very precise, very small tip, like in the net, and under 10 nanometers, right? And they would pass it across the material, and they'd be able to, through electrical variation, measuring that, they'd be able to essentially map out and then graphically represent atoms. And with that in microscope, they were able to affect certain configurations of matter and with energy, and in turn, they're able to write out the name IBM.
Oh wow!
and nanometers, right? So this was a big deal, etching that onto a very tiny plate. But the idea, of course, is that can you actually take advantage of this technology, or is it just a little playground, right? What's it really mean, right? What is its use when
Well,
you start
everything
looking at
around
this?
us is built, or everything around us was created, with atoms and molecules, right? Like I said, it's the building blocks of life. So I guess the idea is that if they can figure out how to manipulate that, then they can, create things from scratch, right? They can
Yeah,
create, objects and things from scratch, essentially, as opposed to taking things that already exist. So it's a real, like, different level of creation, essentially, right?
yeah, and we're talking about creating structures of very tiny size and then building them up. A good example, of course, is carbon, right? Carbon tubes or carbon nanotubes, and that's what they did is, of course, is started creating these or grow these types of we'll call them structures, right? And they've measured out their capabilities, and carbon filaments are able to represent or demonstrate exceptional strength and tensile and elastic strength, and also electrical conductivity and thermal conductivity. So these this material that they were able to create from a very small scale, um, basically was able to demonstrate some amazing properties. So of course, the idea is, okay, well, what do we do with this, right? And what can we do with this? And from a point of view of not only all the different fields, but what can we do, from a point of view of the actual processes to create such small, materials. So that's where things were, exceptionally interesting. It was the processes involved and the discoveries involved of how to do, how to manipulate matter, right, at that level. And of course, it was pretty exotic at the beginning. Things were exceptionally cold, minus 60 Kelvin. But when you start thinking about how do you grow or how do you manufacture something, it's not like we have little tools of that size to cleave objects. A lot of this stuff is being done, by electrical and chemical processes, right, to build these little devices. So that's kind of what happens, from a point of view of the technology initially, and then you have to scale up to a commercial, commercial processes to build these, these materials, and then from there, what is it you're trying to achieve? So if you look at nanomaterials, you can reduce size, you can improve, conductivity. You can not only make things lighter and that, but you can also make them stronger. So what does that mean? Well, improvements in solar batteries or solar cells, improvements in batteries. Also, building components that are exceptionally light but very, very strong. It's an area of ongoing evolution, whether it be utilization of new types of printing technologies or new chemical processes, right, to build these complicated structures. So that being said, the idea here is to figure out and apply this technology in different methods, right? Um, Whether it be coordinating or introducing like carbon filaments into steel, for instance, to improve strength, right, of the native steel. This is where I would say we'll call it material science steps in, right? Trying to understand how certain elements can, be melded together. Uh, Also, there's some pretty groundbreaking research being done at this nano level for plastic replacement,
Mm-hmm.
right? So another, recent, we'll call it fairly recent discovery was they take they're building these materials out of starches that are essentially biodegradable, and they don't they don't have the downfall of the plastics, right, where um, plastics basically just simply don't degrade. We get these microplastics in our systems. Well, the idea of thinking about um, working at that small particle level with an extreme density. You also have improved permeability or reduced permeability. So you can essentially have lower water and oxygen and gas and aroma being able to escape through the membranes that are being created. You can also
So we're
block
essentially
UV.
re-engineering things that
Yeah.
exist and making them more efficient or stronger and those types of things. Then.
Well, it's only understanding at a very small level what the building blocks are, the materials, and then working upwards from that. So we think about carbon filaments. What was that? What was that submarine that just basically exploded? The Titanic.
Oh,
It
they
was,
had the underwater one that went
yeah,
down to do the expedition type thing and just got crushed under the weight.
yeah. Now, I mean, that was a catastrophic failure. Um, I mean, to put that in context, they had taken that vessel down, I don't know, a dozen times. I know that in a lot of cases, especially with some of the standards that have been built through the Navy, they would put a vessel down that was made of steel, um, and they would go that deep, and then they would come up, and that would be the last time it would be retired due to stress, and yet this vessel kept going down. So in the end, it was one of those things where it's just material science is just being pushed to the limit, and ignorance of the owner and the operator to think that things don't wear out under that type of stress, right? But regardless, carbon filaments are exceptionally strong, and they're be created through nanofibers. The they're used in bike frames or bulletproof vests and robot arms and sailboat hulls and safety wear. And they're even used to purify water.
Or in
And
aerospace as well, right? You talked about
yeah,
like deep space exploration. Well, then you have the opposite in space where you need very resilient materials. You're going through the atmosphere of Earth. You're putting it through a lot the same way as if you're going deep beneath the sea, right?
Exactly the same stresses, right? Well, maybe not the same stresses. You're having vacuum and you've got extreme temperature changes. Um, but as well, you think about I don't know, Venus, for instance. Any kind of probe sent to Venus, there's some extreme
Yeah.
pressures there, right? And those particular probes, I think the longest one lasted only a few hours. So it's through this science that we can create these machines that can withstand the extreme conditions, and with that, it opens up discovery, right? So
Hmm.
yeah, I think this moving forward with this type of technology. I mean, often they don't know where it's going to go, but it's a situation where you're doing the science ahead, but the application quickly falls behind, right? So with that in mind, one interesting one I saw was the creation of tiny nanoball bearings, and then putting those little ball bearings in lubricants or oils, right? So essentially, you've got these tiny little ball bearings, and you know they are can essentially take a lot of extreme stress, right? So the life of your oil, is extended incredibly past its the standard
Oh,
life,
okay.
right? Um, so these are also you look at carbon fibers that are introduced into things like tires, right? The technology in tires. We should get in there. We should do one just on tires. It's
Whole episode
crazy.
on tires.
No, nobody really thinks about it. Just get in your car and drive, right? But yeah, some exceptional technology
We could have a
involved there.
topic on that. There was a horror movie in which the killer in the movie was a tire that was rolling around town murdering people. So I
Oh
mean,
my goodness!
I think
Yeah,
I don't know what the movie was called. It might have been called Tire or something like that. But if they can do that, I guess we can do a whole episode on tire technology,
yeah, or killer tomatoes. Those work too.
right?
Yeah. So yeah. So
Well, it was called
that's
Rubber. The
one
movie
side of
the
it.
movie was
Was
called
materials.
Rubber. It was from 2010.
Robert,
It's called Rubber.
where's your rubber at?
Oh man, all right, I have to
Stay
edit
on the road there.
that out. A movie about a
Yeah.
malevolent telekinetic tire.
Oh. With little nanobots
He
inside of it.
he does the killing through a psychic ability.
Wow.
I mean, there's a premise for a movie right there.
Let's get beyond the effect of tires. Now, I don't know if you've ever seen this, but have you ever seen a tire explode? Yeah,
No, I've had one kind of explode on me from hitting a pothole in the road. It's pretty jarring.
it
Um,
is. Yeah.
the way it hit
Yeah.
the pothole was that it just went right through the tire instantly, like bam, and then the car just started immediately swerving off the road. I mean, it was a sort of a fairly violent incident. Thankfully, nothing bad happened to me or the car really, other than having to replace the tire. But,
Oh, you did get off lucky. Yeah, I think if you look on video, you see a guy had a tractor tire on YouTube, um, and he's filling it up, and it blew up, and it blew the side of the truck box right off. I don't understand how he wasn't killed. Right? People get killed from tire explosions all the time, and I guess this is why you start looking at these modern technologies and you infuse them into the vulcanized rubber and everything to make it that much stronger. So you don't get these. I mean, people are getting the industry actually has cages that you put a tire in to fill it up as safety measures.
mm,
Especially the big tires, right? They're real big truck tires. People get killed by those far too often. Not that your standard car tire per se, where you're filling up to 35 pounds. It's these truck tires, right? That have gone through many miles and been retreaded. Yeah, it's so new technology like this helps with the strength and overall, safety, right?
I bet. Yeah.
Yeah. So on the material side, some amazing developments there, and then there's some really, I'll call it weird and wonderful stuff being created, like nanosensors, right? And these sensors here are being made to, measure many different things like gases or temperature, um, and from that perspective, they look at the chemical processes and how they react within the nanotube, and they can change resistance electrically. There's also some uh, particular sensors that have been developed that can actually work from a biological point of view.
Mm.
They can sense certain biological compounds, and react to specific enzymes and things like that. Um,
So, what is it about the nanotechnology that enables those? Like, I think when a lot of us think about nanotechnology, we think about, sort of shrinking things down, right? Like we started talking about Honey, I Shrunk the Kids in a
yeah,
humorous way, right? That we're shrinking things down. Really, it's about manipulating things at a subatomic type level, right? Microscopic level. So, what is it about the technology that allows you to create things like nanosensors and imaging and that type of thing?
well, like I said, it's the processes of creating these things. It's fairly exotic, and they create uh, these structures that have specific properties, and then when they subject those structures to specific gases, and that they can isolate you know uh, basically resistance and or conductivity,
Mm.
and with that they can detect these, how much different gases are within you know the environment, right? So it's a process of, I would say, they start with they start with the device, and then they go through a range of different gases and tests to form to understand, and build up these graphic representations. And you can feed these into a computer, and oh geez, you can even use AI, and with that you can have it actually look at a range of different gases, right? For instance,
Mm-hmm.
um, and you think about it, where the Enterprise is hovering across, it's an orbiting a planet, and somehow the sensors are able to read the atmosphere, what it's made up of. But in reality, what you'd have to do is send a probe down with all these exotic measuring devices, which would be constructed these nano materials, to break down and isolate what the atmosphere contains, right? And with that, then you could beam that up to Scotty, right? And you'd have a pretty good idea of what the atmosphere is, above and beyond the standard methods that we utilize through microscopic, basically light travel, where we can derive a lot of this the environments of or the atmospheres of the planets, right? Just by looking at how light shifts through it.
Yeah, they've looked at that, I believe, as well on some small scale about how they could transport, right, a
Yeah.
small animal or what have you, the way they did in Star Trek, if I'm not mistaken. Unless that's something I saw in a movie, but I believe they've sort of played around with that when it comes to sort of the idea of manipulating atoms, right? If they can figure out how to manipulate the building blocks of life, then theoretically, if they could transport that and reassemble it on the other side, we'd have a whole new way to get to work in the morning.
I wouldn't want to be. I'd be like the little Brundlefly, right? His parts start falling off. No, I'm not going through that. Sorry.
Oh, you
Yeah.
never know where it's going to go, right? It'll save you the hassle of being stuck in the commute, stuck in traffic. You might get killed by a rogue tire.
Yeah, that's
Um,
true.
a telekinetic tire might attack you on your way to work.
Well, we're autonomous vehicles, autonomous tires, right?
So you
That's
never
great.
know where this podcast is going to go,
That's
folks. We
right.
started with technology. We started with
Killer tires.
nanotechnology. We end on killer tires.
Yeah, yeah. Okay, so another thing that, of course, that nanomedicine is, and this is where if you watch Elysium or a lot of sci-fi, well, you just inject the little nanites into your bloodstream, and they run around and they heal you, right? You just
Mm,
healed. Your arm's falling off. Oh no, you grow your new arm. There's no problem, right? Um,
sure.
yeah, because the nanites are there, right? We can't do it biologically, but the nanites will make it happen. Um,
That's, I mean, on a serious note, I mean, that's really where these things start to have a big impact across different industries, like you said in medicine, and there's a lot of things happening there in terms of even on a basic level, right? They're creating sort of a pill where you can swallow a nano robot, and then that'll basically work its way all the way down through your digestive tract and out through the other nether regions and provide video and whatever else they need. Which if anybody's ever been through a colonoscopy, I'd much prefer to swallow a robot pill, a nano pill, than go through that again. But anyway.
okay, so where we're at today is not about growing back your arm or healing every disease out there, but we are doing some interesting things, like for instance with cancer. Now we're able to target the this particular cancer tumor cells um, with nanoparticles. And with that in mind, um, you know, for instance, they were able to coat certain animal particles with this, biogel, and then it's with antibodies, and then it locks onto these cells, and then they can take magnets. Right, this is where it kills you. You put it in a magnetic field, and these things rotate. There's like a little drill.
Oh
you,
wow.
you basically, yeah, you kill you basically remotely destroy the tumor. It's
Oh
pretty
wow.
wild stuff. Yeah, yeah. So so the idea of where that can go. I mean, will it ever get to the point where you're injecting these tiny little super robots into your system, and then they can just essentially reassemble you? Not so sure about that. That's still on the side, on the science fiction side of things. But it's amazing. Some of this technology is truly amazing, right? Okay, so that's another thing. The other, we also get into thinking about energy production, and we talked about building better solar cells. Um, but what's really interesting here is the method of construction of new materials that are superconductors that work at normal temperature for batteries and supercapacitors. Right. This is where things get interesting. You know, think about you're in your car. Currently your Teslas and what have you, and you get your supercharger, and you still got to wait 45 minutes to half hour anyway. Minimum to charge up. Right. How do you make that almost instantaneous? You get out and you fill your car up with gas. It takes you a few minutes, right? How do you achieve that, right? With electrical capacity, being able to convey that much energy electrically into storage over a very, very short amount of time, right? This is where you get into these exotic materials, right?
Yeah, for sure. We're going to need that in order to have a more full adoption of electric vehicles, if that's the direction we want to go in, and
Yeah.
kind of sort of wean off fossil fuels, as it were. And I mean, there's lots of debates around the environmental costs of creating these electric vehicles, but by and large, I think the adoption has been slowed by the practicality of it. Like you said, that you're traveling somewhere and that you're running out of electricity. And now I've heard stories of people having to wait at a charging station, for an hour or two,
Yeah.
to get a full charge to continue on. I did see some recent advancements where they've been able to get that down to like a half an hour or something.
Yeah, the
Um,
supercharger ones, right? But not
yeah,
everyone
yeah.
is a supercharger either, right? So,
Well, exactly. But it's
yeah,
this type of technology that could transform that, right? Because they're trying to move buses, public transit to be electric, trains, like lots of things that they believe there's an advantage, right? Because despite the environmental side of burning gas and burning fuels, it's not an infinite resource, right?
yeah,
There's still, I mean, there's lots of it to go around, but I'm assuming eventually we'll just sort of, for the most part, run out, until we find alternate ways to produce energy. If we can make things like this more practical, then people are going to be more likely to use it, I think.
yeah. We just gotta, basically open up that dark pyramid in Alaska, and we will find all the energy we need, right?
Well, don't
So,
worry. Elon's going to take us to Mars. We're going to colonize Mars. We'll find all the oil we need over there, and then we'll have to figure out how to ship it back to Earth.
yeah, helium-3, right? Helium-3 to get us there. Okay,
Yeah.
so yeah, when we think about this is where we talked about water purification, right? This is really important stuff here. Building better filtration systems, right? And
Hmm.
if you think about it, we have, I can't quote the numbers right now, but you know, if we compare, what we call, drinkable water to the salt water that's on the planet, um, it's a pittance, right? It's hardly anything at all, and we have a huge water supply problem throughout every country. Um, you know, of course, probably the Western countries are a lot better off, but we still have, water supply issues. And Las Vegas is one when it comes to mind. This massive city they built out in the middle of the desert and it's expanded, and now they have huge water problems, right? So when you think about it,
California as well, right?
yeah, yeah, absolutely, they are. And so this idea of desalinization and nano layer filtration is just incredibly important to continue to evolve, right? And also, it's also about filtering the waste as well. So the idea is, putting the water back into the environment that's cleaner than, what you well, as clean as possible. Let's put it that way, without
Hopefully, yeah.
yeah, without damaging the environment, right? So lots of work being done in that point of view, right? So let's think about nanomachines, right? We might as well get there because everybody likes to talk about little
Now
machines.
we're getting to the fun stuff, right?
Yeah.
Come with me if you want to live.
So yeah, so the T2000, I think he was made of that, liquid nanites, right?
Nanites, yeah.
Yeah, he's you can't kill that guy. You end up you can freeze him and he puts himself together again. It's amazing. But what really happens right now? What can we build, right? That are kind of fairly tiny machines, right? So we can build little mechanical or molecular motors. We can build little switches, and we can make little devices that go from A to B, with little propellers and little pumps, right? Um, is it you know T2000 technology? No, sorry,
Not quite.
not quite. Yeah, but it can even modify, and this is where it's kind of scary as they look at modifying or synthesizing the properties of DNA and RNA, right? Um,
Mm.
on the biological side, right? Um, so the other thing too is, of course, electrochemical or chemical types of processes, engines, right? And this is an area which we're still learning about, right? We don't understand our own biology, right? Well enough to understand how, because basically it's biochemical processes that occur within our body that produce, basically run the processes and the energy for each, cellular level, right?
We're applying, biological principles to things that would more traditionally be more technology based, right?
Mm-hmm.
Um, computers, machines, that type of thing. So it's kind of interesting that for a long time we were trying to make, machines and robots seem more human, and now we're trying to, kind of bridge that gap in like a different way, I suppose, if you think about it.
Yeah, like the mitochondria, for instance. The Krebs cycle, all that. It's all chemical, right? Chemistry that occurs there, but it essentially runs or conveys the power system for each cell, and from a biological point of view, these were bacteria and viruses and everything that were incorporated in a cell over millions of years, whatever, what have you. Um, Evolutionary or creationist, I don't care. The idea is that your cell now has all these different components in it, and mitochondria are your little energy producers, and it's all this, this chemistry that occurs, that creates basically this power. Now, that being said, you know, um, do we understand everything and how everything works? No, we're still working on some of that, right? To truly understand and mimic that on a nano basis, right? Build tiny machines that work similar to what we have in a biological system. Not quite there yet, right? But this goes into a whole new area now, right? Of
Mm.
where we think about robots today utilizing mechanical systems. Then you can look at nanomechanical systems that you're able to produce these tiny we'll call them nanomechanical controls and nanomechanical um, devices that make up as a whole a device, right? It's essentially like building a biological entity.
Like the T3000.
Like, yeah. So yeah, okay. Maybe it's down the road. I don't know.
Hey, who
Yeah.
knows? I mean, we always joke that these are the things of science fiction, and then we turn on our computer in the morning or a mobile device, and then we see something that we thought would never happen, and here it is. People have figured out how to create it, so it's not that far fetched that at some point this will make a leap, especially when you start factoring in AI and quantum computing, which we talked about a couple episodes ago, right? Where we're getting into that molecular level of things.
Yeah.
Almost anything's possible. It kind of goes to show that there's something really special about the universe and us and the building blocks of life. That because, like I said before, now we're trying to sort of replicate that in the technology world, whereas before we were trying to make something that was sort of synthetic in a way, right? And we're using materials and zeros and ones, and now we're sort of moving to this more molecular biological bent on computing because we feel like it's going to have so much more power and possibility. It's interesting to see it in that kind of light. We always think the machines are going to replace us, but maybe eventually we'll just become one with the machines.
Yeah. We'll just have our little nanites, and we'll live forever. You know, there's no degradation ever. Yeah. Yeah.
No.
And that's the interesting part about aging, right? Is that first off, we are aging every day. But what is aging, right? Aging, essentially, your cells only have a certain amount of life in them, and then
Mm-hmm.
they create new cells and get replaced. And every time you get a new generation of cells, there's a tiny, 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 tiny fraction of degradation that occurs, and over the lifetime, your cells get replaced so many times that there's this degeneration starts to become apparent, and there you get your gray hair or you go bald, but
Yeah.
you lose muscle mass, whatever happens when you get old. We don't know anything about that, but eventually, yeah, the end comes, and we're glad it's there because we've had enough. you know, that's the human for you, right?
But that seems to be the goal ultimately, right? Like we talked about in some previous episodes about this kind of merging of man and machine, right? In terms of, cyborgs and human augmentation and the computer brain interface. And we're sort of figuring out how to bridge that gap in a sense, right? And I think
Yeah,
somewhere we have this idea that, your spirit and what makes you you will just continue to live on forever. That even when we die, or theoretically, our molecules end up back in the universe and that type of thing. I guess I'm getting very esoteric here, but in a sense, if you think about it, if they were able to figure that out, then really they could create a shell out of technology, and then you could just live forever, right? We always talk about that. That seems to be the ultimate goal, although I'm not sure all of us want to live forever.
well, the argument could be that we're living in a world that we built that isn't perfect. It's very, very imperfect. It's closer to hell than heaven, right, so to speak, and from a point of view of our definition.
I still remember it's funny sometimes where we end up, like we're talking, because when you said that, all I could think about was my father told me a story once that was in some way was meant to be a joke, I suppose, but not in a traditional sense. So my father always had a bit of a dark sense of humor as well, and I don't know if I'll get the story right or the narrative, but someone was talking to this woman about her husband passing away, and talking in terms of people talk about the afterlife and that type of thing, right? And said, well, what do you think now that George is gone? Where do you think George ended up? You think he ended up in heaven and hell? And she said, well, my God, I hope he ended up in heaven because he lived in hell his whole life. I
Isn't that
don't
the
know what the
truth?
backstory was to that, but anyway.
Yeah, yeah. Anyway, when you start thinking about our uh, trying to defeat the natural course of life, we've been trying to do that for a long time, and it's had, a bunch of people pursuing the fountain of youth, uh, and yeah, ultimately there's no way of defeating, the biological clock, right? You can just extend it, but it's going to come up and catch you, right? So, that being said, are these technologies going to help? Are they going to be, kind of allow us to live a little bit longer, maybe 150 years old instead of 100, right? Possibly. I mean, who knows, right? But of course, with any budding technology, when we start introducing these tiny little, devices in our body, and we start, engineering things, and what are we going to do, right? We're going to end up messing things up, right? And
Potentially, yeah,
yeah,
we're playing with the building blocks of life. In some
yeah,
ways, people would say we're playing God, right? That we're really getting deep into the universe and changing things. And what's the result going to be from that?
yeah. I mean, the exotic types of, materials that they're made of, are they toxic to the body? What's the long term health effects? What can happen to the brain? If these things can pass the blood brain barrier, which they can because they're so small. It just goes on and on, right? So utilization of this technology. Who's going to be the first? Are you want to be the guinea pig? So to speak. You want to be the one, the first, try that little nanite shot in the arm.
I don't know. Come back and talk to me in 10 years, maybe. Yeah.
I guess if you're desperate enough, right? So there's that. Plus, like everything else, this is a new technology. What happens if, right? If this turns out to be very poisonous and toxic to the environment?
But I guess like any new technology, we don't know the long term effects, and that goes for
Yeah,
just about everything. But now we're getting into a very different sort of realm, as it were, right? That
yeah,
we really, this is not like trying to invent a new radio or a new car tire.
yeah,
We're getting to the building blocks of life and manipulating our bodies, manipulating the environment, and there's
yeah.
certainly a lot of things that can happen as a result, right?
Yeah, so we've definitely have that and long term exposure issues that we don't understand, and of course, you know, with any technology that's putting, we know what's safe and what isn't. Do we know how to handle certain things, how to manage, safely these types of technologies? Probably not, So yeah, we have that. Plus, we have um, the unknown, right, and unintended consequences, right. So there's lots of hazards and risks with these new types of technologies, and we need to keep diligent, maintain our diligence and ensure that we're doing our best to, ensure that we're not poisoning our environment or ourselves, right?
Well, also there's the potential for misuse or in hands of evil what could be done, right? And certainly there's this type of technology could be used for certain types of weapons or
Yeah,
surveillance or what have you. We didn't really get into that side of things, but certainly if you're talking about anything at a nano level that can get inside a body, could it be used to create some sort of new virus? I mean, we thought COVID was bad. Wait
yeah.
till we get the nano COVID coming out.
Well, I'm sure that you could you could build nanobots that essentially could target components within the cell and essentially kill the whole body, right? And do that very fast. I'm fairly sure we have the capability of doing that. Now, right? So that all being said, um, weaponizing, yeah. Who the hell is insane enough to do that?
Yeah.
So when we think about all this technology, where's it all going? Well, I think this one it's going slowly because of it's you need to get really close to the chemicals and the in the materials and you can't work very quickly because everything's very tiny.
Well, that's maybe where the robots come in. We keep talking about the fact that they have tiny feet and
Tiny,
tiny hands. So
tiny.
now
Yeah.
the AI powered robots are
That's
going to
right. Yeah,
take over.
yeah, yeah. But I would say that we're going to see a lot of diversity of technologies in the robots too, right? They're going to be incorporating a lot of these nanomaterials because they want to make them smaller, lighter, faster, stronger, super capabilities, super conducting, blah blah blah, right? So the big push will be how can we create these on a mass scale, this material on a mass scale, and yeah, that'll be the challenge, right? It'll be um, somebody's got to figure this out, right? And
Yeah, like
go
every
from there.
field now, we talked recently about quantum computing and some other areas, and AI is something that's accelerating, the pace of technology, and I'm sure this will really be no different as well, right? We're tackling these challenges at a molecular level. You start applying some level of AI and robotics and things, it's definitely going to accelerate from there, right?
It's a convergence of all these technologies. That's where you get to the next level, right? And of course, we could all have this problem solved if we go to Alaska, like I said, and find that damn dark pyramid. We'd be laughing. But
That will be good.
yeah, yeah. Anyway, I don't have the specific story behind the Dark Pyramid in the link or anything like that. So you'll have to do your own digging.
Yeah, I was going to ask you what the Dark Pyramid was, but
Yeah.
that's for everybody out there to go dig into and find
That's
out.
right. They can comment on it. What they find. If the the men in black don't show up on their door before they. Yeah.
Yeah, well, I'm just looking forward to living forever. That's my next
Oh.
thing. This. I think if we can both achieve that, then this podcast can just
Go on.
keep going. It'll be like, welcome to season 428, episode 4 of the Probability Podcast.
Yeah, it'd be like two AIs talking together, and you're like, blah 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 blah.
I'll be like, haven't these guys died yet? And then all of a sudden it'll be,
I'll be back.
Thank you for listening to the Probability Podcast. Please join us next time for more musings from the generator and the discriminator.